Hello. So in this video, I wanted to talk about the vocabulary of x-intercepts, how we can find those, how we list them out, and then also the idea of positive and negative intervals on a graph. So first up, hopefully everyone's familiar with the vocab of an x-intercept. X-intercepts are quite, as um, the name of the term would entail, the place or places where a given graph, such as this quadratic from before, previous videos have been dealing with this quadratic equation, places where that graph, and by graph I'm referring to the parabola that's drawn here in orange, the places where that intersects our x-axis, hence the x-axis intercepts. Here there are these 2 points right here. They're very easy to pull from a graph because usually they will be nice numbers that your graph will pass through. Notice I drew this by hand, so it's not quite going through, but I did label the point nonetheless. From the table of values I went through, you'll notice that it appears at 1, 0, and 5, 0. Every x-intercept is going to have a y value of 0, hence you see the zeros here, and that just references that the y value, if you look at the y-axis, is at 0 for those 2 points. And so in this way, the important information we're going to pull from a x-intercept is the location of those x-intercepts. Now the word location in math typically refers, when you're talking about a graph, to the inputs, or in this case, the x values. So the location of those x-intercepts, the x value of those x-intercepts, here are going to be 1 and 5. And boom. So there we go. There is the x-intercepts. And now I'm going to talk briefly about the positive versus negative intervals. So first of all, we need to understand what we're talking about when we say positive. Y values, as opposed to x values, which are location, y values are denoting the value of a given function, of a given relationship. Here, that's up and down, and you can think y values, it's a positive side up here and a negative side on the bottom. So it's positive top, negative on bottom. And the separation between those two is this x-axis. Now these x-intercepts happen to be the points where your graph has a value of 0. Anything above that, so this little arc up here, for instance, would have a positive y value, and down here on either side, as I go left and left and left, and to the right and right and right from either x-intercept, in this case, towards the extremes of the graph, the value is below this x-axis, it's way down here, and so over these areas, these portions of your graph here, and again the word graph referring to the parabola, there would be a negative y value. And so we use intervals, like we will for domain and range, we will use intervals here to basically tell us, okay, so when can I expect this graph to be positive? When can I expect it to be negative? Because visually on a graph, it's easy to see, but to write it down such that you don't need a graph to see when it's going to be positive or negative is also a useful thing to do. So if you notice, I'm going to start with the positives. Between these two x-intercepts, so between positive 1, and again, x is going to denote the location, so that's what we're going to use. X values are location. Between 1 and 5, between those x values, the x values between, such as 1 or 2, 3, and 4, and all the numbers between 1 and 5 that are like decimals, and pretty much every real number between them, that's going to be when your graph is a value that is positive. And so what we're going to do is simply just write that we're going to have the x values that are between 1 and 5. Now, I'll stress when we're talking about intervals, and usually you have to infer from context, or you can write the word interval here. This is not a point. This is not the point 1, 5. If you notice 1, 5, that's 1, 5 is not even on your graph. Rather, this is saying everything between 1 and 5 is going to be where your graph is positive. Now, it sometimes helps to write this little notation here, which just says x values that are this thing. For us, it's just going to say in or on. So you read this as like x in the interval 1 to 5, or x on the interval 1 to 5, or x belongs to. the interval 1 to 5, that is going to be where we have a positive y value. Now, negative intervals, you may notice, is pretty much everything on either side of 1, or in this case 5. In particular, it's everything to the left. If you notice, if I trace my curve, I'm moving to the left very slowly, but surely to the left of positive 1. And the x value here, the location starts at 5, and then it goes to the right. Now, when it comes to quadratics, if you just kept going to the left forever and ever and ever, it's going to essentially represent the idea of tending towards negative infinity. If I just kept going this way, that's going to be negative infinity in terms of location. If I went to the right forever and ever, that would be positive infinity. And so the negative intervals, we have, well, we're going to say everything that's between negative infinity up until positive 1, which again here is like all of this side of the graph, everything that's over here, everything to the left, so to speak, if I were to highlight this, everything over here on your graph, and then everything to the right of positive 5, which we can write as everything between 5 and positive infinity. Again, this half of the interval, in this case, is referring to 5 and to the right, or more positive, and this is like 1 and to the left, more negative. Everything in either of those two, which we're going to combine with what we call a union, which you notice it looks like a U for union. It's basically saying put these two together. Everything in either one of these two intervals, collections of locations, x values here, everything on either side in either of these shaded regions is going to be where we have a negative value for your graph. Cool, so that is our intervals and our x-intercepts. And yeah.